Okay. Now, we don't just need to use the data frames data directly. We can also derive the data frames data, such as correlation. Now, we learned in data analytics section of discussion how to generate the correlation from the data frame. So it's simply df.core, right? And then we talked about replacing the diagonal ones with zeros to make them uninteresting. And once we get this sort of neutralized correlation data frame, it will be a square data frame, right? It will be A correlate with A correlate with B, with C with D, B correlate with A, B, C, D, and so on. So it will be symmetrical across the diagonal. So we just basically pipe the whole thing in. And again, since core is a data frame, we can heat map the data frame. So now, because it is very visual, it is trying to partner our eyes to be the holistic investigation apparatus. And therefore, we need to choose our color map very carefully. Because here, if you choose the yellow, orange, brown thing, it probably will miss out showing up the very negatively correlated values or pairs of columns. So here, for example, when we perform this cool warm, we're using the standard name cool warm because Seaborn already has internally pre-built color palettes. That means range of colors that are kind of related to each other. Much like Matplotlib internally has pre-built or pre-understood the color codes of standard colors like red, green, blue, orange, yellow. So it understands all these. It doesn't require us to enter the decimal or integers very carefully. So here Seaborn is one level higher in that it has a name for the entire color palette. So when we just refer to the standard name coolwarm, and how do I know this? Just check out Seaborn's documentation. They list out the color palette as well as the color image itself, so it's quite easily and conveniently usable. So CMAP equals to cool warm color, which is this scale here. You can just think of the color map as this scale here, and then dot set title. So you see that the call convention is exactly the same. The data frame CMAP equals to what color map. These are the most important part, the data and the color map choice. And then set the title. So what's being shown here? According to the color map, extremely high positive correlations will show up as dark red. Extremely negative, because remember, correlation values go from -1 to 1. So extremely negative will be very interesting. The larger a column goes, the lower another column goes very consistently. As opposed to positive correlation, the higher the column goes, the also the higher the other column goes, right? So they are kind of moving in sync pretty reliably, and we like to know which two columns behave like that. So now imagine we don't know how the data frame data was captured. Someone just throw us this data frame to analyze. Okay, then what should we do? Well, first thing first is, are they having some sort of latent connections? For example, if we have a population demographics data frame, so it'll be huge, right? It'll be huge. It will have captured a lot of parameters of the citizen, maybe 30 columns. Now, one might wonder which are the ones that are kind of related. So for example, income versus years of education. In some countries, it might exhibit strong correlation because there are opportunities and all that. But in other countries, high number of years of education may not result in high income. So that correlation may not be universal. It may be demographically dependent, in country-wise dependent, and so on. So without assuming anything, we like to analyze the correlations of the data. And the easiest way is just run a heat map over the correlation. So that's great. Yeah. Next, let's look at another very powerful device that Seaborn offers among so many, right? But these two are the most powerful: heat map and pair plot. So pair plot is really, really a powerful function. Why? Because as we mentioned, scatter plot from pandas is really, really useful to examine two columns, two variables, two sets of measurements. Are they exhibiting some sort of linear correlation or else non-linear correlation even? Because correlation, the dot core, shows us linear correlation feature. So in certain instances, two columns might exhibit, very, very good connections, very good influence on one another in a, I don't know, in a maybe a circular way, in a parabolic way, in certain ways that might weaken. That means their correlations will show off as nearly zero or very low values. Well, because they don't have linear correlation, but they have circular correlations. All right, so correlations can show the relationship, but only linear relationship. Scatter plot, on the other hand, assumes nothing. Assumes nothing. You see linear relationship if you see the lines, or rather the dots, the data cloud, show up as clouding around a line. It may be a sort of a gradient 1 line, a gradient 15 line, a gradient 0.5 line, or negative gradient line, and so on. So if they gather, congregate around the line, that's linear pattern. And the corresponding correlation should show up as well. However, if the columns don't correlate as line, but they show up as some sort of a curve, so they dot along an invisible line that's exhibiting like a curve-like kind of feature, then we can see it, right? We can definitely see it and immediately register in our minds something interesting is happening there, right? Whereas correlation might show as weak correlation. It's true because it's weak line, linear correlation, but strong curvilinear correlation, but we don't have a formula to calculate that, right? Neither did we know that it is going to be curved this way, not an S way or W curve way and whatnot. We have no idea. So scatter plots of all columns with all columns, that's the most powerful and most computationally intensive plot. So it might take a while. If you have 4,000 columns, you can run and forget it for, I don't know, leave it for 10 hours. So but it's worth the wait because when it comes back, you don't see 5,000 numbers presented to you. You see very nice plots like these. One look at it, we kind of can convince ourselves, nothing interesting, right? And not at least for this display here. Or it might tell us, I think there might be something, but the data is just too scarce. So let's gather more data. Let's wait a bit more for more information to show up. And then we pair plot again. So in any case, it is going to tell us something. Even if it tells us nothing, that is a very important nothing. Because until then, we have no idea. All right, you're not able to confidently tell your customer, tell your boss, tell your management. There's no relationship there until we have certain